Assalamu alaikum and welcome to Cambridge Chemistry channel with Sarwat Ahmed. Be sure to like the video and subscribe it. Really helps the channel to grow. Today I will start solubility product. In this lesson I will explain definition, units and calculation of the solubility product. You know that solubility of a substance at a given temperature is its amount that would saturate 1 decimeter cube of the solvent when it is in contact with the solid solute. So write on the definition. Solubility. What is solubility? What is solubility? Solubility actually solubility of a substance at a given temperature is its amount that would saturate one decimeter cube of the solvent when it is in contact with the solid solute. So this is the solubility, and the amount of substance is expressed, we know that amount of substance is expressed in moles or in grams. The amount of substance expressed in moles or grams. Hence the unit of solubility may be the units of solubility is mole dm inverse cube or gram dm inverse cube. Sometimes the amount of the solvent may be expressed in kilograms. So, but this is the standard unit of the solubility. There is no salt that is completely insoluble in water. The salts that we usually refer to as insoluble do in fact dissolve to some extent. Therefore, the term sparingly soluble is used perfectly instead of insoluble. So, the solubility product. What do you mean by solubility product? Solubility product or Ksp, represented with Ksp. So, what does it means? The solubility product product of a salt is the product of the concentrations of the ions in the saturated solution of the salt raised to the appropriate parts. Ksp is constant. Ksp is constant as long as temperature remain constant. So consider a saturated solution of a sparingly soluble salt in contact with a solid solute. In this state, there is equilibrium between the undissolved salt and its ions in solution. The equilibrium is shown like, for example, if we have silver chloride solid insoluble salt, that is Ag aqueous, chloride ion aqueous. So this is equilibrium is established in this reaction, and we know that the equilibrium, when there is equilibrium established, the Kc is equal to concentration of silver ion product over reactant and concentration of chloride ion divided by concentration of silver chloride solid. We know that silver chloride is constant solid silver, so Kc into AgCl solid is equal to Ksp. So Ksp expression now will be Ksp is equal to concentration of silver ion and concentration of solid ion. Chloride ion. In case of saturated solution, concentration of the solid in contact is constant. Hence, in case of so that's why this expression is written Ksp is equal to concentration of silver ion and concentration of solid ion. Ksp is constant. Ksp is constant called the solubility product. So there is another example in a saturated solution of Pb lead chloride, the following equilibrium is set up. PbCl2 solid, Pb2 positive plus 2Cl negative. So therefore the solubility expression is Ksp is equal to concentration of lead ion and concentration of Cl negative ion raised power to 2. So this is the expression of solubility product. Calculation of Ksp from solubility. Ksp of PbCl2, where solubility of PbCl2 is 1.22 into 10 raised power to minus 3. So we know that PbCl2 solid, so it is equal to lead 2 ion, equilibrium 2 positive aqueous plus 2Cl negative. So solubility of lead 2 chloride is 1.22 into 10 raised power minus 3. So the solubility of ion, because ratio 1 is to 1, so the solubility of lead to ion is 1.22 into 10 raised power to minus 3 mole dm inverse cube. Similarly, this is 1:2, and the solubility of this will be equal to 2.44 into 10 raised power to minus 3. So let's say this is the change. Initial is, for example, if it is A, and this is initial, and the solubility of lead to ion 0, this is 0. This is change, that if it is this and 1.22 into 2, and you know the solid is ignored equilibrium. At equilibrium this is ignored, and this is equal to 1.22 into 10 raised power to minus 3 and 2.44 into 10 raised power to minus 3. So we know the Ksp expression. Ksp is equal to lead to positive concentration of lead ion, concentration of chloride ion, appropriate power, and we know the value 1.22 into 10 raised power to minus 3 and this is raised power to 2.44 into 10 raised power to minus 3 raised power 2, which is equal to 7.26 into 10 raised power minus 9, and the unit is mole cube dm inverse 9. So the unit is unit of Ksp can be derived like this: Pb mole dm inverse cube, this is square mole dm inverse cube into mole dm inverse cube. So the unit will be mole cube dm inverse 9. So there is another question: calculate solubility of CDS cadmium sulfide is 1.46 into 10 raised power 2 minus 11 mole dm cube. So the equation is Ct cadmium sulfide aqueous plus 2 negative aqueous ion. Initial mole E, this is 0 and this is 0. The change mole is 1.46 into 10 raised power 2 minus 11. This is 1.46 into 10 raised power 2 minus 11, and this is 1.46 into 10 raised power 2 minus 11. The Ksp the change is equilibrium, at equilibrium. Solid is ignored always in concentration, equilibrium, reaction, Kc, Kp, etc. This is 1.46 equilibrium mole, 1.46 into 10 raised power 2 minus 11. So Ksp expression is cadmium 2 positive, sulfide 2 negative, and 1.46 into 10 raised power 2 minus 11, 1.46 into 10 raised power 2 minus 11. The answer will be 2.13 into 10 raised power 2 minus 2, and the unit will be mole square dm inverse cube. So we can derive like this: mole dm inverse cube into mole dm inverse cube, so which is equal to mole square dm inverse 6. There is another way to calculate the Ksp, like for example next question: Solubility product of PbCl2, Ksp of PbCl2 at 25 degrees centigrade is 1.70 into 10 raised power 2 minus 5 mole cube dm inverse 9. Calculate the solubility of lead chloride at 25 degrees centigrade. So lead chloride ionizes like Pb 2 positive to Cl negative. Suppose the solubility of PbCl2 at 25 degrees centigrade is x mole per dm cube. Then the concentration of the two ions in the equilibrium mixtures are, if the concentration of Pb2 positive will be x mole dm inverse cube and chloride ion will be equal to 2x. Solubility product of Ksp of lead chloride is as follows. Ksp is equal to Pb2 positive Cl negative. Now solubility product will be 1.70 into 10 raised power 2 minus 5, where x Pb, the value of Pb is x and value of Cl chloride ion is 2x here. So this is equal to 1.70 into 10 raised power 2 minus 5 equal to 4x cube. So 4x cube is 4x cube is equal to 1.70 into 10 raised power 2 minus 5 divided by 4 is equal to x cube. So x is equal to cube root 1.70 into 10 raised power 2 minus 5 over 4, which is equal to, now x is equal to 1.62 into 10 raised power minus 2 mole dm inverse cube. Therefore, the solubility of PbCl2 is equal to 1.62 into 10 raised power 2 minus 2 mole dm inverse cube. So we know that mr of PbCl2 is, lead is 207 plus chlorine 35.5 into 2, which is equal to 278 gram. Therefore, solubility of PbCl2 at 25 degrees centigrade in gram, this is mole per dm cube. If we want to convert into gram, if we want to find out the solubility of PbCl2 in gram dm cube inverse cube, then it is equal to mole into mr. Mole is 1.62 into 10 raised power 2 minus 2, mr is 278. So now the solubility is in gram per decimeter cube, 4.50 gram dm inverse cube. This is solubility of PbCl2 in gram decimeter inverse cube. Hope you will like this video. Please subscribe it. Like the video.